All right, zooming right along. Now we're going on into section 2. And again, you really need your calculator. Okay, so get prepared. Make sure you've got it. Pause the video if you don't have it. Today is 5-2, and let me get this heading up here. Okay, and it is rates and unit rates. I'll make sure you can see all that. Okay, rates and unit rates, chapter 5, section 2. Awesome. You see these a lot already in real world practice, so this is a great example on how we work with it. All right, so today's learning target is basically learning about I can calculate rates and unit rates. Rates and unit rates. Okie dokie. And you definitely need your calculator. All right. Well, first things first, we better define what a rate is. So make sure you've got that up there. A rate is a special kind of ratio. So in other words, it's a comparison of two numbers. But the big deal here is that this ratio or fraction with two different numbers has different units associated with it. Okay? Like, what do you mean? I mean, like, I went on a trip and I drove to visit my mom and dad. And when I go to visit my mom and dad up in the Great White North in Virginia, Minnesota, it's 220 miles. And it took me, let's just, I had to stop and, grab a snack, eat a little, go to the bathroom, that kind of thing. So it took me 220 miles in 4 hours. I'm comparing two numbers, 220 and 4, but they have different units, miles and hours. So oftentimes when we read these, the division bar, the fraction bar there is when we say the word per. Okay, 220 miles per 4 hours or in 4 hours. Okay, now in this case, it doesn't really make sense to use the word per. However, when we get to a unit rate is a special kind of rate, and the denominator is 1. Now, what do I mean by that? Well, here's what I mean. Here was my example of a rate, 220 miles in 4 hours. If you grab your calculator and take and divide these two and take 220 divided by 4, okay, you would end up with the number 55. And 55 then is like 55 over 1. In a sense, it's like you're taking the numerator and dividing by 4, the denominator divided by 4. You end up with 55 over 1, and keep those labels in the numerator and the denominator. Miles, hours. Here's a unit rate. My average speed was 55 miles per hour, per 1 hour. There's where that word per really makes sense. Okay? That's what a unit rate is. So let's take a look at a few. You have to write down all these words, but write this down. Penelope can type 90 words in 2 minutes. Hey, how fast can you type without making mistakes? 90 words in 2 minutes. So maybe the in is also a clue as to where the fraction bar goes. And, oh, did you catch that mistake? Hello, can you tell that I am a little sleepy and hungry right now? The top label should not be minutes. It is words. 90 words in 2 minutes. 90 words in 2 minutes. Okay, that's a rate. Boom. If I said find the unit rate, that means you take whatever's in this denominator, you do the division, 90 divided by 2. Now I'm still going to have a fraction. Okay. I'm still going to have words in the numerator, minutes in the denominator, but now my denominator is going to be 1 when I divide these two together, because 90 divided by 2 is 45. Think of that as 45 over 1. 45 words per minute. There you go. All right. You know I love hockey. So here we go. Let's say, and these stats might be a little old, but let's say Mikko Koivu had 54 points last season. Points in hockey is for goals and the assists, okay? 54. He played 65 games this last season, I should say. Okay. What is the rate of his points per game? So I'm asking you for the unit rate now. Okay. Now, this is not going to be pretty. I can tell you right now, because usually what happens in real life, the numbers don't work out pretty. So these are the points, and the denominator 65 is games. Okay. 54 points and 65 games. What is that as a unit rate? So I want to know how much is that for one game. Okay, now we're doing some calculation here. So I'm not going to be able to do this in my head. So grab your handy dandy calculator and say 54 divided by 65. And you get this ishkabibble decimal that goes on a long ways. And it must be repeating somewhere, but I don't have enough digits in my display to tell exactly where. So here we go. Squiggly equal sign means approximately equal to. I'm going to have to round this off. Let's go to 2 decimal places, the hundredths place. This is about 0.83 or 83 hundredths of a goal per game. Now, is that realistic? Or I should say points, right? Points. No, but statistically, I mean, Mikko's not going to score 0.83 of a goal every single game, but this is an average. So we're talking he almost scores a point a game. That's pretty awesome for a hockey player. Okay? Keep up the good work. We want to get to the playoffs, man. All right. There's an instance of using your calculator. All right, let's look at something a little more realistic. And actually, now this number is probably off because this example is a number of years old now. But let's just say the population of the United States is around 300 million people. Okay? In the House of Representatives, there are 435 members. And the way the representation is figured, and they calculate it every year, or every 10 years once they do the census to see if they need to do some shifting with how these 435 members of the House are allocated amongst the states. But basically, here's what I'm asking. What is the rate of the population to the representatives? Now, it's still people to people, but it's different people. So the first thing first, 300 million, and these would be regular citizens here, okay, to 435 representatives. I'm going to abbreviate that as rep. Now that's the rate. 300 million is such a big number, I can't fathom that. So let's make the unit rate. And I know I'm going to have to approximate here. But about how many people then does one representative account for? Or what is their job to represent? So watch your zeros here. 1, 2, 3, 4, 5, 6, 7, 8 zeros for 300 million. Divided by 435. Okay, now I don't know about you, but I get this big old decimal here, and I'm going to have to write it down. It goes 6, 8, 9, 6, 5, 5, and then I get a decimal, like 0.1, blah, 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 and it keeps going. I'm going to round it off because I'm talking about people, and I don't really want to talk about parts of people. That's creepy. So I'm going to round this. So about every member of the House of Representatives represents on average almost 690,000 people. That's a lot of people. Okay. That's not quite the same as, that's less than the whole metro area in Minneapolis and St. Paul together, but it's a lot of people getting there. Okay. Now, what if I say just estimate? So put the calculator down and don't touch it. If I say estimate the unit rate, and I've got students to computers here, okay? So I'm thinking a fraction, students over computers, and I've got 468 and 91. Now usually, okay, so if I were grabbing a calculator, I would just divide this and go. But I want to just estimate and approximate. So let's pick a number that's decent to divide by here, okay? And personally, 91 is really close to 100, and that's pretty close, okay? Computers. 468 students, nah, I mean, I suppose you could say either 450 or 500 approximately if I round it up a little bit. Okay, 400, that many students. Now this is an easy one to do in my head because I can divide by 100 and I would get 5 to 1. Okay, so approximately 5 students for every 1 computer in the building. Okay, that would be an approximation or an estimate. If you wanted to see how close you are really, go ahead and grab a calculator and check. It's probably fairly close. Okay, how about this one? Estimate. So don't you dare grab your calculator. Okay, 313 feet, 8 seconds. Now, in this case, you know what? When I'm thinking 8 and I'm thinking multiples of 8, I know 32 is a multiple of 8. And in this case, I'm going to do something a little weird here, okay? I'm going to say, you know what? If I called this close to 320 feet and rounded it up that way, and 8 seconds, this works nice because 8 can go into 32 4 times. And so that means 8 can go into 320 40 times. Nice. 40 feet per second. That's pretty close. Okay. Okay. Let's see. How about this one? 583 players. And then we've got 85 soccer balls. 85 soccer balls. Okay, now this one's a little more challenging, but work with me here. Let's see. Going up to 100 might be kind of big. So I'm going to choose 90 in this case. Maybe I should have done that on that first one too. Now, when I look at 90, I want you to just look at the 9, 99999. And now I got to look at 583. And let's just, for a moment, just take a look. 583. Cover up that 3 for a moment and just look at the 50s and a 9. When I think multiples of 9, okay, and I'm thinking, 9, 18, 27, 36, 45, 54, and 60. You know what? This is kind of close to a multiple of 54. If I rounded this down to about 540, that might be fairly close, because then I'd round it like this and I'd say, well, then divide by 10, then this is like 6 to 1 ratio, and that's pretty close. Granted, when you're estimating, the whole point is just kind of get a ballpark figure. It's not going to be exact. It's not going to be perfect, but you don't always want the exact decimal. You're just saying, oh, so we got about 6 players per soccer ball. Okay. All right. There you go. Now is when it gets fun. This is what I love to do. Do you ever go shopping and you'll notice there's a sticker or a label underneath the item on the product? And when you really look inside there, it will actually tell you what the unit rate is. So you're shopping, okay? Peanut butter. In my house, we used to buy this ginormous can of it, okay? It was ridiculous how much peanut butter we would go through. So what's the better buy, okay? When you go to those warehouse places, the bigger thing isn't always the better buy. You really should do the math. So is this jar that costs $2.60 for 2 pounds, is that better than getting a $6.54 can that has 5 pounds? Which one is really the better deal? All right, grab your calculator. Let's crank them out, okay? Let's see. This one, you get 1.30 exactly over 1. So it's $1.30 for every pound. When you do this one, grab your calculator, punch in 6.54, divide it by 5, and you get this, 1.308. Now, I know for 1 pound. I know money usually only goes to the hundredths place, and this would force it to round up to be $1.31. The big point here is, even though it's a bigger can, it actually costs more per pound, not a lot, but a little, than the smaller one. The small jar is the better buy. It's actually cheaper per pound. Let's talk about Mountain Dew. Okay. Costs $1.50 for a 20-ounce bottle. $1.50 for 20 ounces. Okay, find out the unit rate of that guy. Grab your calculator and crank it out. You do it at the same time I'm going to do it. 0.075 per 1 ounce. Now, this is money, okay? Right here, this is money. This is what it equaled, which basically is like 7.5 cents per ounce. Okay, now let's take a look at the 6-pack, okay? A 6-pack has 6 cans in it. Each can is 12 ounces. So you're paying $3.99, and make sure you're using the same units, ounces. Okay, it's not 6 ounces. No, it's 6 cans. It's not 12 ounces because that's just 1 can. It's 6 times 12 ounces, which is 72. Got to make sure we're on the same units here. All right, this one I know for sure I cannot do in my head. $3.99 divided by 72 is, when you crank that out on your calculator, here's what you get. 0.055. And do you notice how this goes on and on and on? But the big thing I want you to notice here is that this number, 0.55, is smaller than 0.75. That means the 6-pack is the better buy. Okay? You're actually paying less per ounce of soda. See why you need the calculator today? Awesome. All right, your assignment is in your workbook. Turn to page 33. All right, and I think it looks like this. It should say lesson 5.2. So double check me. Sometimes I mess up on the page numbers in your workbook, but look for this heading. You've got to have a calculator, and you have to make sure you label your answers. You must have a fraction, that you have a numerator and a denominator, and put the words or the labels in there, because the number won't mean anything until you have the labels in there. All righty? Awesome. Here you go. Once again, get going on your assignment. Good luck, and as always, may the force be with you.